Alright, in this video we're going to do a quiz on composition of functions and transformation of graphs. So if g of x is f of x plus 2, and they ask us to describe the graph of g of x in terms of the graph of x, of f, we're going to say, okay, if we replace x with x plus 2 on the inside of the function, that's going to be a horizontal change. Adding is going to be a shift, and if we're adding 2 on the inside, that corresponds to a shift left by 2. So I would say this shifts left 2 units. Over here we've got the graph of y equals g of x. If f of x is g of x minus 3 on the outside like that, that's just going to move the graph down by 3. So give a sketch of the graph of f on the figure. So we're just going to kind of go down by whatever we think 3 is, maybe like negative 3 down here. And then I'm going to try to just go more or less parallel to the, best I can, and that'll be good enough. Now, h is the quadratic function x squared plus 2x plus 5. Write a formula for h of 3x, we can do that. Wherever we see x in the formula for h, we're going to replace it with 3x. But I always like to recommend you replace it in parentheses, so I'm going to go over here and I'm going to say h of a thing is that thing squared plus 2 times that thing plus 5. So if we were to plug in, 3x, we do that here and there. And, in my class, I think that's actually a decent place to stop. That's a formula for h of 3x. It's not totally simplified. If you were going to, you needed to simplify that as 9x squared, right? Because if you're squaring 3x, you'd have 2 3's and 2 x's. 2 times 3x would be 6x and 5, okay, if you wanted to. Okay, and then describe the graph of h of 3x in terms of the graph of y equals h of x. Okay, on the inside, that's going to be a horizontal transform. Multiplication is a stretch or compression. Since it's multiplied on the inside by 3, it's going to be a compression by a factor of like a third. Okay, I meant to say that's going to be a horizontal compression. By a factor of 1/3. Alright, now we've got f of x and g of x. Write an equation for f of g of x and g of f of x. So if we're going to do f of g of x, okay, f of something is that thing plus 5. Okay, so if I was to plug in g of x, let's be replacing x everywhere I saw it in the formula with g of x, but then we kind of want an explicit formula, and g of x is square root of x, so this would be square root of x plus 5. Then we can do the same thing for g of f of x. G of something equals the square root of that thing. And so if we were to plug in f of x here, we plug in f of x there. And f of x is equal to x plus 5, so this is going to be, oh no. Okay, that actually wasn't that bad. Wondering if I still have the rest of my pages. Be equal to the square root of x plus 5. Number 6 is if f of x equals x cubed plus 2x and the graph of g is formed by vertically stretching the graph of f by a factor of 6. Okay, that means g of x is we're going to take f of x, and if it's a stretch, we're going to multiply. If it's vertical, we're going to multiply on the outside by a factor of 6. So I'm going to just write 6 times f of x. And that's going to equal 6 times x cubed plus 2x. And if you left it there on the quiz, we gave you full credit. But if you wanted to simplify this, you needed to be simplifying it properly. So we would need to be distributing the 6 over the x cubed and the 2x. So we'd have 6x cubed plus 12x. Here we've got the graph of y equals h of x and table for f and g. Alright, so we're just going to kind of do these composition of function things. Okay, first with this, I'm going to figure out what h of 2 is. So I can figure out what I'm plugging into f. So I'm going to go over here to the table, and I'm going to say, alright, I'm looking for h of 2. And so I'm going to go over here to where x is equal to 2. Oh no, where x is equal to 2 on the graph. I'm going to look up there. I'm going to see a y-coordinate of 1. So I'm going to say h of 2 equals 1. And then f of h of 2 is going to be f of 1. And you look in the table, f of 1, that's going to equal 5. And the value of g of 3, we would need to figure out what g of 3 is first. And so that would be over here on the table. No, that's g of 5. I'm looking for g of 3, which is 5. Okay, so I'm seeing that. And so then g of 3 would equal g of 5, which is that's gonna equal 4. Well, and I guess that's it for Form A. So let's move on to Form B. Okay, Form B. So g of x equals f of x minus 2 on the outside. We're going to describe the graph of g of x in terms of the graph of f of x. So if we're subtracting or adding, that corresponds to a shift of the graph. If we're doing that on the outside, that's going to be a vertical shift. So I'm going to just say shift down because the subtracting 2, shift down 2 units. And then over here, the second one, here we've got the graph of g, and f is g of x plus 3. So what you're supposed to do here is say, okay, addition is a shift happening on the inside, that's horizontal, so we know it's going to go left by 3 units, because adding on the inside shifts to the left. So we're going to go over here, we're going to move the graph left by 3. Unfortunately, it's over here at x equals 3, so that kind of relative minimum there, that's going to happen at the origin, and I'm just going to otherwise try to keep it as parallel as possible. It's not perfect, and that's going to be my sketch. Yeah, it went left by 3 units. It's otherwise unchanged. All right. Now, number 3 and 4 are talking about this quadratic function, h of x equals x squared plus 2x plus 5. And if we're going to write a formula for h of 4x, we're going to take, wherever we see x in the formula for h, we're going to replace it with 4x. So what h does is it takes a number, it squares it, it adds 2 times that number, and then adds 5. So we're going to plug in 4x here, wherever we saw x before. And, okay, we could stop there if we wanted, or we could, actually multiply it out. 4x squared would be 4 squared times x squared. 2 times 4x, and 5. If we were to describe the graph of y equals h of 4x in terms of the graph of y equals h of x, okay, multiplication is a stretch or a compression. On the inside is going to be a horizontal stretch. And since we're multiplying by 4, it'll be, it kind of works the opposite of the way we expect. It's going to be a compression by a factor of 1/4. Right, now if f of x is cube root of x and g of x is x minus 1, find f of g of x and g of f of x. All right, so f of something equals the cube root of that thing. And we're going to plug in g of x. We're going to have g of x there, and g of x is x minus 1, so this will be the cube root of x minus 1. And then g of f of x, okay, what happens to something with g? G takes a number and it subtracts 1. So if I was to plug in f of x here, have f of x there, and f of x is cube root x, so that would be cube root of x minus 1. Alright, if f is x to the 4 plus 3x and g is a vertical stretch of f by a factor of 5, alright, so what would happen there is vertical stretch is we're going to multiply on the outside. Multiplying because of the stretching, on the outside because it's vertical. And so we're going to take f of x and we're going to multiply it by 5 on the outside. And that's what g of x is going to be. But like an actual formula for g of x, that would be in terms of x. So that would be 5 times x to the 4 plus 3x, if you wanted to stop there. Or if you wanted to distribute it, you could say that was 5x to the 4 plus 15x. Alright, so now we've got table for f and g and a graph for h. if we want to find h of f of 3, first we kind of just need to start on the inside and find the value of f of 3. So let's say, all right, f of 3 is going to be equal to, I find x equals 3 on the table, I go over to f, and I'm getting 2. So h of f of 3 is going to be h of 2, and that's going to be, okay, I go over to the graph, I go up 1 when I'm at x equals 2, so h of 2 equals 1. And then g of 4, first I got to figure out what g of 4 is. I'm going to go to the table, go to the x equals 4, look at g, that's going to be 1. So say g of 4 equals 1, so g of 4 is equal to g of, g of 1, and g of 1 is going to equal 2. Okay, and that's all for this quiz. That's it. Thanks for watching.